Hello there, welcome to A-Level Physics and Mathematics. In this section, I will break down projectile motion of an object for you guys. Before that, could you please just like, share, and then subscribe this video for your friend. So, projectile motion, maybe you can see this in high school grade, maybe in 12 or if you are a senior high school student maybe you are familiar with this session. So projectile motion means a motion of an object with initial velocity, and then projectile motion is a motion of an object projected with initial velocity v naught. We say like v naught or v sub and allowed to freely move to down or under the influence of acceleration or a gravity is called a projectile motion. Or in simple word, you can define a projectile motion. Projectile motion means a motion of an object moves along a curved path under the influence of a gravity is called projectile motion. Bear in mind here, like I said, we need to have a motion projected with some initial velocity v naught is known as a projectile motion. So ይህ ማለት ደግሞ ምን ማለት ነው? projectile motion እንደዚህ demonstrate ማድረግ ትችላላችሁ. Let's say if an object is here or maybe you can say particle, ይህን particle እንደዚህ move ሲያደርግ or let's say ይሄ object እዚህ ጋር ካለበት projected or launched ሲሆን we call it a projectile motion. As you know, this is v naught x, and then this guy is called v naught y, and then this is speed or the velocity of a projected projected object. So we call it we can represent y by v naught. So let's say here object ከዚህ እንቅስቃሴ ሲጀምር or project or launch ሲያደርግ that motion of an object or that motion of a body is called a projectile motion. So we can represent look like this. Let's say if an object start from, let's say this is a curved path. So let's say if an object is launched, ይሄ object ከዚህ ወደዚህ move ሲያደርግ or projected, we can say a projected or a launched. So a v naught could be look like this, and then the vx or the horizontal component of vx or the horizontal component of x is represented by this, and then the vertical component is look like this. Is supposed to be a y. So this is a vertical component of the projected object or a projectile motion. So this motion of an object is called, like I said, is a projectile motion. So I believe you understand the projectile motion. Now, if you have any question, please feel free to put in the comment section. I am happy to reply for you guys. So just to recall what I said, if an object is, let's say if an object is here, and then if this object start or projected along the curved path, like this, then that the motion of that object is called a projectile motion. That is all about a projectile motion definition. Like I said, let me know if you have any question. I'm happy to reply for you guys. And then there is an example of a brief example of a projectile motion. So let's proceed with an example. So the example says a projectile, a cannonball is projected from the edge of cliff that is 80 meters. That is the height of the cliff is 18 meter high from the ground. Okay, and then we have also the ball is launched from this cliff. The ball is launched, or the cannonball is launched from this cliff by the speed of 30 meter per second, and then with an angle 30 degrees above the cliff. So those are a given parameter to find out a couple of parameters. So the first question says determine the horizontal range of this cannonball, okay? And then we need the second question is maximum height of this projectile or cannonball, and then the velocity of this projectile cannonball at 3 seconds after launch it. So those are the requested or the question that we need to calculate. So let's represent this launched, the cannonball projection or projected. So ይሄን demonstrate ለማድረግ እንደምናደርገው let's say we have a cliff over here. This is a cliff. Let's say this is a cliff, and then this is a ground. Okay, this is a ground. We have a height from the ground, which is 80 meters, or we call it a y naught. Y naught is 80 meter, which is y naught, which is 80 meter, and then the cannonball. Let's look like this. Let me represent for you guys, and then this is a cannonball launched from the cliff. Let's say here ball. If we have a cannonball over here, and then this ball, if this ball is launched from this point or from the cliff to the ground, look like this. Okay, this is how projectile ይሄ cos ከዚህ ወደዚህ projected ሲያደርግ እነዚህን parameter እንዴት determine ማድረግ እንችላለን. So to find out this is a maximum point or a maximum height. This is a maximum height. Let me show you guys. So this is a y max. Okay, this is a y max, and then let's find out the given parameter first. What we can do is let's say a given parameter is we have y naught. We have y naught, which is equal to 80 meter, and then we have a speed which is v naught is equal to 30 meter per second, and then we have time as well. We have what is that? We have a theta. We have an angle theta from here. Basically, we need to find out the x parameter as well as the ball is launched with the speed v naught, and then we have v sub x. V sub x, and then also we have v naught, or the initial component of horizontal velocity is y, which is given by v sub o y. So we have an angle theta over here, an angle theta over here. The angle theta is look like this. So which is 30 degree. So those are a couple of parameters, and then one important thing that you need to understand about the projectile motion: the acceleration of a horizontal component is 0. Don't forget this point. The acceleration of horizontal component is always 0, which is ax is equal to 0. Those are these are another given parameter, and then the gravitational force is downward, which is a is equal to ay is equal to minus g. These are another given parameter, as well as the other parameter that you need to the y component, initial or the total height, or y naught is equal to 80 meters. As you can see here, the other parameter that you need to know is acceleration due to gravity is 9.8 meter per second, which is a acceleration due to gravity is g is equal to 9.8 meter per second. Those are important parameters that you need to understand to calculate this example. So here what we need to know is there is a couple of things that you need to understand, and then from the example that you can see from here, a ball is launched from a cliff to this point, and then as you can see in this query, the question is said that the velocity of the projectile motion, find the velocity of the projectile motion after 3 seconds. Let's say this ball is launched or projected after 3 seconds. Maybe you can find out somewhere around here. Don't worry about the position. Maybe this is just one instance. So we have instantaneous velocity over here. We have instantaneous speed or velocity over here. And then you have y component, the x component, as well as y component over here as well, or the vertical component as well as the horizontal component, which is v naught x as well as v naught y, which is this is velocity of the projectile, or the speed of a projectile projected object or a projectile motion. So we need to, since we are looking the projectile motion separately, so we need to break down this speed. So what we can do is from this we have from this what we can do is from this point this v sub x, v sub or x is equal to v naught cosine of theta, and then which is equal to as well as v naught y sine of theta, or let me show you guys over here. V naught is equal to v sub or sine of theta, and then v sub x, when v sub or sub x is equal to v naught cosine of cosine of theta. So we need to find out the horizontal component as well as the vertical component using this parameter. So now those are given parameter that you need to find out. So what we can do is let's proceed with the first example, which is say that before that what we can do is we need to find out all equation that you need to use in the projectile motion. Let's proceed over here. So what we can do is as you know, from the kinematics equation, which is let me show you over here. From kinematics equation, I believe you are familiar with that, you guys. From kinematics equation, what we can do is from this kinematics equation, I believe you are familiar with that, which is displacement equation as well as the velocity equation, which is the displacement equation is equal to S is equal to S naught plus V naught T plus 1/2 A T squared, and then the velocity equation is equal to U naught. We can say U naught, or we can use this or semicolon over here. So V is equal to U naught plus a T. This is kinematics equation. I believe you are familiar with that. So from this we can derive the all equation that will help us to find out the projectile motion. So from this we can, by the way, here we have an x, which is x from this. This is an x. This is an x. I'm sorry about that. We have an x, which is x, or the horizontal range is x. So from this example, we can calculate x is equal to x naught plus which is v naught t, v naught time t is equal v naught time t plus 1 upon 2 t square. Basically this term is, as you can see from here, v naught x, or the velocity along the x component, is equal to v naught cosine of theta. So x is equal to x naught plus v naught cosine of theta plus, and then acceleration. Basically, this acceleration is equal to 0 because there is no acceleration along the horizontal line. Therefore, this term is 0. So we left with also this term is 0 because we have the object, the initial position of an object is 0. Then we call this term is 0 as well. So x is equal to v naught x cosine of theta time t, which is equation 1. Let's say this is an equation 1. So we can calculate the horizontal range using this equation. Next, the velocity of the horizontal component. So v of x is equal to, then v of x, let me just double confirm over here. So v of vx is equal to, it's supposed to be vx is equal to vx is equal to v x plus v naught. It's supposed to be a v naught x is equal to a t. So we can derive from this, which is from this equation. So vx is equal to this term is, like I said, this term is equal to cosine v naught cosine of theta. So meaning that the horizontal component of, or the horizontal speed is equal to v naught cosine of theta is that. Let's say this is a second equation. We can calculate the horizontal component using this equation. So next is this is basically you can say this is in x direction. This term is in x direction. We can say this is in x direction. We can find, or the horizontal component of the projectile motion, which is range as well as the velocity of the projectile motion. So what we can do is in y direction we can find out both a couple of parameters basically. So from this equation, from this kinematics equation, what we can do is y is equal to y naught plus v sub o sub t plus 1 upon 2. A is acceleration due to gravity time. or multiplied by time. So this term is equal to V naught sine of theta. Then this term is basically over here. So the y is equal to y naught plus v naught sine of theta, and then plus, and then acceleration due to gravity is, the acceleration due to gravity is basically it's a downward, so meaning that the direction or this negative sign basically indicate the direction of acceleration due to gravity upon 2 g multiplied by t. This is a third equation that will help you to find out motion of an object or a projectile motion of an object. So this is a displacement, and then the velocity of an object is equal to, let me just double confirm over here. So the y component is equal to u, or basically over here we can use also a u. It doesn't matter, basically it's a final velocity. So I believe you're familiar with that. So what we can do is over here the horizontal component is equal to is supposed to be, yes, basically we can represent it like this, so it doesn't matter. So the velocity of a vertical component is given by v naught sub y plus a t square, or a sub y t at. So meaning that this term is acceleration due to gravity. So vy, or the velocity of y, is equal to minus gt, which is the fourth equation, or we can calculate the velocity of basically this term, like I said, this term is equal to this term is equal to, or so this term is equal to vy is equal to, this is v naught sine of theta. So v, you can plug into this, so v naught sine of theta minus gt, which is this is equation 4, which will help you to find out acceleration due to gravity. So the velocity of a vertical component, I'm sorry about that, it will help you to find out the velocity of a vertical component. So I think that is all. Now what we can do is we can proceed with this example. Let's calculate over here. So we have all parameters right now. So to find out basically there is a couple of required. So which is horizontal range A, let's say required term is horizontal range A is horizontal range, which is x, or range B is let me just confirm, B is a maximum height, B is a maximum height, I'm sorry about that, heights, and then C is velocity, V at 3 seconds after launch. Those are required terms. So to find out, let me just clear this part. to find a horizontal range, what we can do is we can use this equation, but as you can see, we don't have time. So basically, the horizontal range is calculated by V naught cosine of V naught cosine of theta time t. This is an equation that will help you to calculate the horizontal range. So we don't have time, or as you can see, we don't have time to calculate time. What we can do is we need to use one of the equation from this. So let's use this equation. So because let me just confirm over here. Okay, so what we can do is, we can use this example, because basically I just want to let you know from the horizon, from the cliff at this point. Let's say at this point, as you know, the maximum height is Vy, or we call it Vy. Basically, Vy is equal to 0, which is a displacement, or the maximum height of the projectile motion, which is equal to 0, or basically we can say y is equal to 0. So what we can do is calculate is like I said, we can use this equation. So meaning that y is equal to y naught plus v naught sine of theta plus what was that, or minus 1 upon 2 gt square. So we can just plug all given term over here, which is 18 meter, and then like I said, the y is equal to 0, which is equal to 80 meter plus this term is 30 plus times sine of theta, which is 30 degree, and then minus 1 upon 2 gt square. So when you calculate this term, you will find out approximately, let's say t is equal to basically you can find 4.9 t square minus 15 t minus 80 meter. So using a quadratic equation, which is minus b plus or minus square root of b square plus minus 4ac upon the whole over 2t. Using this equation, you can calculate this quadratic equation, and then you can find t is equal to 2.79 and t is equal to 5.8 seconds. Basically, we have sec over here, but what you need to understand over here, as you know, this is a negative sign. Basically, this is a negative t. So t cannot be a negative, so we can use this time. So we can plug this time over here to find out the x component, or the horizontal, or the range of the projectile motion, which is equal to v naught cosine of theta time t, which is equal to 30 cosine of theta of, which is 30 degree time multiplied by 5.8 second. So which is equal to, I think you can find out, this one is equal to 1.5. You can multiply approximately, you can get Yes, I think this is an approximate value, but you can get a 150 meter. That is the horizontal range of projectile motion. The horizontal range of x, which is x is 152 meter, is the horizontal projectile motion. And next one is the maximum height. So let's calculate the maximum height of this projectile motion. So what we can do is to find out the horizontal, the maximum height, which is y max b. This one is a, and y max is equal to y naught plus v naught v sub o y cosine of, sine of, it's not a sine of theta plus or minus, basically it's minus 1/2 gt squared. So we can use this equation. We can use this equation to find horizontal, the maximum height of the projectile motion. So what we can do is from this equation, as you know, we don't have time. We don't have time, or we don't have a given time to calculate the maximum height. So we can from this equation 4, we can find which is y is equal to v naught sine theta minus gt. We can find out the time from this equation. So to find the time, vy is equal to v naught sine theta minus gt, which means vy is equal to basically vy is equal to 30 meter, or 30 meter per second, or you can write, or you can, doesn't matter, basically sine theta, which is 30 degree, and then minus 9.8 time t, right, time t, and then this term, basically, like I said here, the maximum and the maximum velocity, or the velocity at the top of the cliff is called 0. So which is equal to 0 is equal to 30 sine of theta, or 30 minus g minus 9.8 times t. So to find the t, what we can do is, which is equal to 9.8 t is equal to 30 sine of theta. I think that's all. So sine of theta, which means 30, and then we can divide it by 9.8 over 9.8. So t is equal to, you can this term is 0.5 times 13, and then you can find out I think 1.5, 1.53 second. Okay, this is a time. Then now we can plug this term into over here, and then you can find out the maximum height. So to calculate the maximum height, what we can do is, like I said, we can use the equation, equation 3. So let me proceed over here. So what we can do is, like I said, y max is equal to y naught plus v naught y sine of theta minus g t square. So which is equal to, y naught is equal to, from the projectile motion from the given, it is equal to 80 meter plus this is v y naught is equal to vy naught is, v sub o y is equal to, this term is 30, right? 30 over 30 sine of theta, which is 30 minus g is 9.8 times t square, which is 1.53 the whole square. So which is equal to what we can find, you can calculate that by yourself. So what we can do is, so y max is equal to, y max is equal to 91.4848 meter. You can find the maximum height of the projectile motion is 91.8, meaning that from the previous picture you can see the maximum height means an object, or the maximum height is this height, or y max is 91.48 meter. Basically, an object is launched from this cliff, right? From the cliff. An object is launched from the cliff. Look like this. Okay? Let's say this is a cannonball. This is a cannonball. This is a cannonball. Let me show you. This is a y max. Y max is 91.48 meter. So basically this is a maximum height, and then the ball is launched from this cliff. The height from this ground to cliff is 80 meter, and then the thing is, what we can do is, so from the distance from cliff, to find out the distance from cliff or above the cliff, what we can do is 91 minus, or 91.48 minus 80 meter. Then this, to find out this height basically, which is equal to 11.48 meter, meaning that the distance from the cliff to the maximum point is equal to 11.48 meter. So let me know if you have any question. So that is it. So the maximum height is basically this guy, which is 91.48. So next we need to calculate the next section. We need to, the next query is C. So to find out the time so after 3 seconds, what we can do is, let me proceed over here. So to find out C, which is it's time, or the velocity. C is a velocity, CT at 3 sec after launch. So to calculate the velocity, basically we need to understand a couple of parameters, which is we need to determine separately, meaning that Vx is equal to, as you know, V naught cosine of theta, and then meaning that Vx is equal to 30, and then cosine of 30 cos of 30 degree, cos of 30 degree, which is equal to, I think it's approximately, maybe we can find 26 meter per second, and then the y component is equal to v naught y, isn't v naught y? Yep, v naught, and then this one is x naught y, and v naught v sub o sub x, and then this guy is v sub o sub y is then sine of theta, then which is equal to, this term is 30 sine of theta, which is 30 degree, which is equal to, we can calculate, oh, I'm sorry about that, basically from this equation, you need to calculate the v naught using this, v, or the speed along the vertical axis. You can calculate using equation, fourth equation, which is minus gt minus gt, and then so we can plug the acceleration due to gravity over here, which is 9.8 time t is equal to 3 seconds. Over here we have a 3 time, so we can get this term around 14.4 meter, 14.4 meter per second, which is the horizontal displacement, the vertical displacement of the projectile motion. So next, what you need to do is basically it's negative 1, because suppose negative 14.4 meter per second. This negative sign indicates that the velocity of an object is projected to downward, which is a negative. It indicates that the negative y direction. So this negative indicates that the projectile motion is projected along the negative y direction. So those are the horizontal component as well as the vertical component. So almost we are done now. So the next what you need to do is basically we have let me show you. We have let's say we can draw this vertical component as well as the horizontal component. Let's say this is horizontal component, and then this guy is a vertical component. So this is a v. This is a v, meaning that the speed of the projectile motion after 3 seconds. Let me show you over here. The object is projected from the cliff. The object of the ball is projected from the cliff. It's look like this, right? So this is a cannonball. Then the ball is projected from here. Then this is an speed, right? This is after 3 seconds, meaning that t is equal to 3 over here. Then this is this v is speed or the velocity of this projectile motion at 3. So this is v, and then this is x term, which is 26 meter per second, and then this is a y parameter, which is equal to minus 14.4 meter per second. So using the Pythagoras theorem or a trigonometric function, trigonometric relationship, we can find out the magnitude of this projectile speed or projectile speed basically. So v is equal to what we can do is, let me check, v is equal to v is equal to square root of v square is equal to v x square plus v y square, which is equal to square root of v is equal to square root of v sub x square plus v sub y square. So v is equal to square root of, you can plug both value. Vx is equal to 26 meter per second plus or minus, basically minus 14.4 meter per second square, meter per second. So we can get V is equal to around 29.72 meter per second. This is the velocity or the speed of the projectile motion after 3 seconds. Now we can find, basically you can also use this one to calculate the Socrates rule, which is Socrates rule or trigonometry function or Pythagoras theorem. To calculate this one, you can use a Socrates rule, which is CAHTOH, which is time, the cosine is equal to adjacent over hypotenuse as well. You can use this rule as well. And then the last guy, what we need to do, find out, this one is a phi. To find out the cosine of cos of phi is equal to cos of phi is equal to, basically we need to use this rule over here to find out the cos of phi. So which means cos of phi is equal to cosine of phi is equal to adjacent over hypotenuse. So adjacent of this angle is equal to 26 meter per second upon, and then hypotenuse is equal to V, which is 29.7 meter, 72 meter per second, which is equal to, we can get 0.8775. This is cosine phi parameter. And then what we can do is to find out that this phi, so phi is equal to cos inverse of the cos inverse of phi is equal to cos inverse of cos inverse. So what we can do is cos inverse, so which is equal to basically 0.875. Then phi is equal to, I think approximately we can find out, you can check by yourself, which is 29 degrees. So this angle is, or phi is equal to basically this angle. We do have y component over here, x component over here, and then y component. This is v y. So these are basically, we use this relationship to find out the cosine or the angle between this angle, basically the angle over here, the angle between the angle between the projectile speed as well as the y component. So this is all about this projectile motion. As I said, to find projectile motion, range of the projectile motion, which is x, is equal to v naught x cosine of theta plus time t. This is a basic equation that will help you to calculate the range of any projectile motion. This one is also velocity. We can derive this from the kinematics equation. We did already that one. But if you have any question, just let me know. And then this is y component. horizontal, I mean the vertical component. This is a vertical component. This is a horizontal component, as well as this one is a vertical component. So these are all about this projectile motion. So let me know if you have any question, and then if you enjoy this video, could you please share, like, and subscribe this video, and then we'll proceed next time. Maybe የአስረኛ ክፍል ተማሪዎች ከሆናችሁ ፕሮጀክታይል ሞሽን ላይ ያለውን ኤክሰርሳይዝ በጠቅላላ ኔክስት ክላስ ላይ እንሰራለን። ስለዚህ ኔክስት ታይም አይ ቲንክ ኢት ዋዝ 2.1 ሜቢ ኤክሰርሳይዝ 2.1 እነዚህን ኤክሰርሳይዝ ኔክስት ክላስ ላይ እንሰራ እንችላለን። ስለዚህ እንደነገርኳቸው ይህን ቪዲዮ ሼር አድርጉ፣ ላይክ አድርጉ፣ ሰብስክራይብ አድርጉ as well, and then let me know if you have any question in the comment section. I'm happy to reply for you guys. That's all for today, and then have a good day. Thank you.